we're going to do Buffon's needle trick. So this is named after Georges-Louis Leclerc. This was a method that he proposed for working out pi. So basically he proposed that you would chuck a bunch of needles on just randomly on a floor. You can work out pi from that, yeah, due to the random nature. So we haven't got needles and we're not going to do it on a floor, we're going to do it on one of Brady's lovely brown pieces of paper. And we're going to use matches instead because we're cheap. So what we want is we want to draw some lines on this. So there's just one line. And what we want is we want the gaps between lines to be 2 matches long. Right, so this is all very approximate. What we're going to do is we're going to chuck a bunch of matches on this board. So I'll just chuck the first 2 completely randomly. We need a lot of matches for this. If I counted these right, we should have 163. Let's just spread them out. So hopefully there should be 163 matches randomly distributed around this board. Now, this is what I've got to do now is I'm going to count how many matches cross a line. Okay, so I reckon that one does. So you counting Brady, that's 1, 2, 3, 5, 6, 11, 12, 13, 14, 51, and I think that's it, 52. 52 matches that cross the lines there. There's 163 in total. Now let's see, let's do the following calculation. So 163 divided by 52 is equal to 3.13, and that's not bad. That's not bad. I'm quite happy with that.
Very close.
Yeah. So pi is 3.141. So this is not bad. Okay, so why isn't it perfect? Because this is not a very large sample. You know, viewers could have a little go themselves. Just literally play the same game. If you've got more matches, that's better. You'll get a better accuracy. There was a mathematician called Lazzarini. He used over 3,000 needles, and he actually managed to get pi accurate to sort of, I think it was about 6 decimal places. What we're seeing here is something it's akin to a Monte Carlo simulation, that's what it's called. You basically take a random sample. The reason you get pi out of this is it's all to do with the angle that the match takes as being sort of, you know, playing some role here. Okay, and of course, if you're working in radians, if you go through a full it's what we call 360 degrees, well in radians that's 2 pi. Okay, so that's where pi is coming into this game, and that's why you can get pi out of this sort of setup because of the angle. So we're going to try and explain the maths of it now. Let me say, imagine that the length of the match is L. Okay, and that means that the distance here is 2L. Here's what there's a few things that play a role here. There's the position of the center of the match, which I'll call there. We'll say that's a distance x from here. And then the other thing that we're interested in is the angle that the match is making. So let's just draw it, I guess, like so. And we're interested in that angle, theta. Assuming everything's completely random, what's the probability density? You know, how do we measure the probability of where the center of the match is? Well, the probability density of the center of the match, which is the position x, is just given by essentially 1 over L. The other thing that we're interested in is the angle that it makes. So this is sort of a measure of the probability of the angle it's making. And basically the angles that we're interested in is somewhere between 0 and pi over 2, which is, of course, 90 degrees. This is where the pi is coming in. Now, if we want to work out essentially the probability of matches for the match to cross the line, what we do is we take these two. We have to do an integration. Okay, now there's an important point here. What's the condition for the match to cross the line? Well, the condition for the match to cross the line is that x should be less than L over 2 sine theta. So that means when we do the x integration, we go between 0 and L over 2 sine theta. Okay, and of course, when we do the theta integration, we're going between 0 and pi by 2. Okay, so we do it. Theta equals 0 to pi by 2. 2 over L pi. 2 over L pi. When we do the x integration, we get an L over 2 sine theta. And then we integrate sine theta between 0 and pi by 2. That gives me 1. And I've got the 1 over pi there, so the answer is 1 over pi. This tells me the probability that you're going to cross the line, right? So if I've got n matches, and I want to work out how many cross, let me call them, so this is the n total, okay, and I want to work out how many cross, then I just multiply n total by 1 over pi. We had one, so n total was 163, and n crossing was 52, I think we got, didn't we? Okay, and so what you see from that is this, we've got 163 over pi, okay, let's put an approximate sign in there, approximately 52, or if you like, what we actually saw was that pi, just rearrange this equation, is approximately 163 over 52. Yeah, I'm happy with that. Yeah, that's good. So that's how it works. That's the theory behind it.